Hey everybody, welcome to episode, I have no idea, of the Tech Security Podcast troubleshooting vlog we're doing here today. This is the same lab setup that we did last time. What we have is clients on the outside that once again cannot access our web server, man. There's something going on here, and we got to figure it out. It's the same topology as before. We've got a client on the outside. It's actually it's not in the 192 network. It's 10.1.1.211. That user is trying to access the web server on the inside of our ASA at 10.3.6.50, and it's trying to access the real IP. So it's sending TCP SYN packets to the IP 10.3.6.50 on port 80, and that's not working. So often in the attack, we're called in to troubleshoot issues like this, where access was working for a while and now it's not. What's going on? And so we're going to walk you through some of the troubleshooting tips we'll use to diagnose this problem. So the first thing, as always, we love capture, so I'll apply a capture to the outside and the inside interface. Cap out interface outside, and we'll use match TCP any EQ80. So we're going to match any TCP port 80 traffic for this test because I know that should be the only TCP port 80 traffic. You wanted to get more specific, you could have matched the specific source and the destination, which would have been a good idea. But in this case, I'm matching all port 80 traffic. And I'll also apply it to the inside interface. Cap in interface inside, match TCP any EQ80. Okay, we're capturing this traffic. Let's take a look. Looks like we've already got some captures on the packets on the outside. Let's take a look at them. Show cap out. And here's our TCP packets sourced from our monitoring server here, 10.1.1.211, destined to the web server on port 80. We've got, these are TCP SYN packets. You can see all our different sequence numbers here, window size, TCP options, maximum segment size of 1460 bytes. Selective ACK is okay, TCP timestamps are being used, and a window scaling factor of 6. These are all normal. If I look at show cap in, I see nothing. That's not good. So we know the packet's ingressing the outside interface. We know that nothing's going out the inside, so something must be going on with this ASA. Either these packets are like corrupted and we're dropping them for a good reason, or some policy on the firewall is blocking them. So let's troubleshoot it. Let's look at the ASP drops. First I'll clear the ASP drop counter, and next we'll do show ASP drop to look at the drops in the accelerated security path. And luckily, since I only have a little bit of traffic flowing through this firewall, I can see that it is no valid adjacency. So this is our ASP drop code for this traffic. We've also got a couple packets denied by an access list. So if you've got more than just a test flow flowing through your ASA, you're going to have to figure out which packets match up with these drop codes, and you can do that by capturing the ASP drop packets. So I'll say cap ASP, type ASP drop all. So what I'm doing here is I'm making a new capture called ASP. It will capture all packets dropped by the accelerated security path. And my drop code, I can specify like a particular drop code. In this case, I'll say all. So now I've got that capture running, and it's a capture just like all the others. And what I'll do is I'll wait a few seconds for the monitoring server to try to connect to the web server, and then once I'm happy that it probably does, I'll say show cap ASP, and it will tell me that, okay, here's our packets, destined to our web server. The drop reason is no dash adjacency, no valid adjacency. And I can click on this because we have a contextual help and highlighting rule here in the Cisco CLI analyzer that talks about what this means, and it means that it has no adjacency to the next hop. We don't know how to get to the next hop to send this packet to. So that's weird because we definitely have a route to that server. So let's do this. Let's take a look at our syslogs. Compt logging buffer debug, logging on, show log, and let's take a look at what we get. Okay, here's our cons. Built localhost on the outside and the DMZ. That's interesting. So we built a localhost on the DMZ for the IP 10.3.6.50, which doesn't make sense because that's our IP address, and it should live on the inside, but it lives on the DMZ, according to this ASA. We also see built inbound TCP connection for outside the DMZ, and then immediately it was torn down due to no valid adjacency. So again, we've got this adjacency issue. And then the local hosts were torn down. So something is like forwarding this packet to the DMZ interface. So the con is being built between outside and DMZ, which is really strange. Check the routing table. If I do a show route, the best route to the 10.3.6.x network is directly on the outside interface. And if I do show route DMZ, you can see here that there's no route to that destination on the DMZ. So why is the ASA taking an inbound packet and forwarding it to the DMZ interface? The only things that could do that besides, say, policy-based routing is NAT. So NAT is probably diverting this packet and virtually forwarding it to an egress interface that doesn't match the routing table. NAT can override the routing table for egress interface selection. And it's always done that ever since the old PIX days, because when you make a NAT statement saying that this network is translated to this other network on this global interface, you're telling the ASA that that network lives behind this other interface and it's mapped to a global on the egress interface. So packets coming in destined to that global address in that translation are going to bypass the routing table and get forwarded to that egress interface that matches the local or real interface of the NAT rule. Okay, so it's just something to understand and be aware of. We can verify which NAT rule it's doing that with packet tracer. Another easy way to see this is, well, one way to be aware of this way, you can do show NAT detail, which will print out all the NAT rules. We saw this last time, and it'll show you the untranslate and translate hits. Now, this is the NAT table. So the NAT configuration is your config policy, which builds the NAT table, which you can view via show NAT detail. And then as connections are built and use this NAT table, they use translations or xlates. So you've got the config, you've got the NAT table, which you can see with show NAT detail, and then you have xlates, which are actually like live running translations. So in this case, we can see here the first, if I run show NAT detail, I can see all my different NAT sections, section 1, section 2, and I'm looking for one of these NAT rules to have translate or untranslate hits. Now, the Cisco CLI Analyzer is highlighting a lot of these because I wrote a rule that says if we see that translate hits is 0, untranslate hits is 0, that means this NAT rule has not been used since the box booted up or the statistics were cleared. So it's a good way to sort of troubleshoot and see which NAT rules aren't being used. And in this case, I can see if I scroll down to number 6, there is a NAT rule from DMZ to outside that has 468 untranslate hits, so it's being used. And show NAT detail shows me the real IP addresses in the NAT rule, so I can see that this is saying the 10.3.6.50/32 host lives on the DMZ, and it is mapped to the outside interface, and its translated IP is 10.3.6.50. So this is an identity translation from the DMZ to the outside, and our inbound packets are matching this NAT rule. Another way I could have proved this is using packet tracer, but I didn't want to jump all the way there because that's the easy way, right? So I can say packet tracer input outside TCP and specify our host is 10.1.1.211, source port 1234, destined to 10.3.6.50 on port 80. This is going to show me the unnat phase, and this is what I'm interested in. This unnat phase is where we translate the destination, and that's where, if you've got destination translation specified, and in this case it is destination translation because the packet's coming in from the outside and it's going to be the destination IP address that NAT rule is changing. So therefore we do that unnat phase before our access list, and it's this unnat phase that can divert the packet to a different interface than the routing table would prefer. So in this case we've got the config is object network, object web server 2. It's a NAT rule someone's put in there, and it says from NAT from DMZ to outside, statically translate it. And we even have a little nice contextual help and highlighting rule that tells about what's going on and explains what the NAT divert action does. So to fix this, I could do several things. I could change the global address. I could change the NAT rule to be inside to outside, but all I'm going to do here is delete the object because we'll pretend that my coworker just added it or fat fingered it, and after doing that I can verify things are working if I do a clear cap/all to clear all the captures. Show cap out proves that, let's see if my packet's coming in the outside interface. It is, and looky there, the three-way handshake has come up. I see lots of data and the con torn down, and if I do show cap in, I can see that packets are correctly being forwarded to the inside interface, And just to be sure, I can say show NAT detail, and I'll probably see hits on a rule lower down. Yes, there it is. The last rule is my legitimate NAT rule that it was hitting before my coworker or someone added the bad host-based NAT rule. Okay, so that's another troubleshooting scenario having to do with NAT, and in this case we have a divert action to an egress interface that overrode the routing table. So this shows you how you can troubleshoot that, and also shows you how the Cisco CLI Analyzer can help you by infusing knowledge right there on your screen as you're doing your work. All right, thanks a lot. Till next time.